we use the method of parametric equations for straight lines in solving this problem. In the setup here, I have a circle, a point inside the circle, a chord passing through the point with inclination angle of 45 degrees. We try to find the length AB. Now for straight line, usually we have a fixed point, x0, y0. The line passing through this point would have the equation in a parameter t. Now here the direction vector is given uv. So for any other point xy on the straight line, we claim that the difference in the x coordinate and the y coordinate is proportional to u and v. In other words, this is proportional. Now we use parameter t to represent this ratio. In other words, this is the t. Now with this setup, we can express the coordinate of xy on the straight line xy in terms of x0, y0, and t. That is like this. Okay, this is called the parametric equation for straight lines. All right. So another common form of this parametric equation is if we're given the instead of the direction vector uv here, we're given the angle of straight line with the x-axis, right? We call it inclination angle. Let's call it alpha. All right, so like this. Now here, once you know alpha, you can know the direction d here in terms of alpha. That is cosine alpha and sine alpha. All right. So of course, in this diagram, alpha is 45 degrees, but in some other setup, you could be greater than 90 degrees, right? The straight line inclination would be different. Now here with this, of course, we can replace u and v now, right? So in another form, in terms of alpha, the equation becomes this. Okay, here in this form, which is frequently used, t has a special meaning. Let's figure it out. Okay, let's try to find out the distance of the point P to the point P0. Of course, we use Pythagorean theorem and distance formula to solve that, right? So we know the coordinate xy and x0, y0, the difference square, right? The sum of square would be this. This would be the distance. Now, of course, with our parameter setup, x minus x0 would become t cosine alpha. The other one would be t sine alpha. Let's plug it in. So this distance becomes, this one. Now, of course, cosine square alpha plus sine square alpha, that's equal to 1. So this value becomes square root of t squared, which is absolute value of t. So you see t has a special meaning. That is, t represents the distance of the point P to the point P0. Of course, t could be negative. Why? Because here we have a direction going upwards here, right? But if you go downwards, go to the other direction, t becomes negative. All right. So in other words, when t is negative, the point goes against the direction vector, right, with respect to the original point P0. Okay. So with this parameter t and the understanding of the distance, P and P0, we can solve the original problem. Let's look at the problem here. The circle, the angle, and the point P here, of course, this would take the role of P0. So let's use the parametric equation of straight line AB here with given alpha. So that is, in this case, the P0's coordinate is 1 and 2, right? X0 is 1, Y0 is 2, so we have this equation here. Now, how do we find A and B? A and B are the points that not only on the straight line, but also on the circle. So we need to plug in this value into the circle equation so that we can solve for t. Once we know the t, we can solve the distance between A and B. All right, so let's do that. Let's plug in. Okay, so let's expand and simplify. It becomes this. Of course, we're given alpha equal 45 degrees, sine and cosine of that equal square root of 2 over 2. So let's combine that, it becomes this. Now notice that this is a quadratic equation. It has two roots. Why? Because discriminant here is positive. So there are two real roots, t1 and t2. So once we find t1, t2, how do we find a, b's length? Now, given our interpretation of the t value, we know that the distance would be the difference of two roots. Of course, absolute value, because it could become negative. All right. So let's look at that. So this is quadratic equation. From here, we know the sum and product of two roots, right? Notice that both of these are negative numbers. Why? Because in our original diagram, you notice that P is very toward to the point B here. So with this setup, A would representing a negative T, and B would be a positive T. So they have an opposite sign, and the negative value is dominant here, right? So that's why the sum is negative, the product is also negative. All right, that's good. So with this, we can find the length by looking at the absolute value of t1 minus t2, which can be calculated from t1 minus t2 squared. Of course, we don't know t1 minus t2, we know t1 plus t2, right? So what we can do is to turn this into t1 plus t2 squared, but then you have to subtract 4 t1 t2 in order to this. Now, we're good to go now, because we know both the summation of the t1, t2, and also the product of t1, t2. Just plug in the numbers. That's 18 plus 12, that's 30. Okay, so the segment length is the square root of 30. Okay, so here we use the parametric equation for straight line in solving the original problem of finding the coordinates of AB. Hope you enjoyed the video. Please like, share, and subscribe.